Now let us see the second example. Right here, you are having data from the question. The question is, how long should a current of 5 ampere be passed through a solution of silver chloride in order to deposit this one? So, we are talking about the time that will be taken by 5 ampere to remain in a solution so as we may deposit this one. Current of 5 ampere. And then mass, deposited mass, this is important, this one. You multiply it, convert into gram. By multiplying by 1,000, you get 3240 gram. This is mass. And Z, the electrochemical equivalent for silver, 1.118 times 10 power less negative 3 gram per coulomb. Now, from M is equal now to ZIT. We are looking for a time. Time is equal to what? What is absent is time. Yes. Now, time is equal now to M over ZI. Now, mass is the 3240 divided by Z is 1.1 times 10 power negative 3 times I is 5. It's all about division. Now, mass, time will be equal now to 5.80 times 10 raised to 5 seconds. Now, the time, once you multiply and you divide, time taken, it was 5.80 times 10 power 5 seconds. This is the time. And this is the result of this one. M is equal to ZIT. What is missing? Now, M is equal now to ZIT. Sometimes you may be asked to find out current. I is equal now to M over ZT. Sometimes you may be requested to determine time. Time is equal now to M over ZI. So it depends on the nature of the question. Here it was all about time. So that's the end of the first Faraday's law of electrolysis.